Hello, so now we will do our acceleration analysis for this mechanism. We will start off by solving for the normal acceleration for link AC, which is in the direction normal to link AC, which is along the link AC. And now with the velocity from our last activity, we now have our normal acceleration in point C. And then to solve for the normal acceleration in point D, we will also use the velocity we got from the last activity, and then with the length of link DB, we now have a normal acceleration at point D of this value. And that is what we will also do with the normal acceleration with DC. And there we have it. Now we will find for the total acceleration for point D. Now we have our arbitrary point Q. We will start off by drawing the normal acceleration at point C, which goes in the direction of link AC. And with the magnitude of this, we can now draw this using our scale of 1 millimeter is equals to 76.76 centimeters per second squared. From there, we will now draw our acceleration normal to DC, which goes along the direction of link DC, and have this magnitude again. So we will now draw that. And then we will now draw the tangential acceleration of DC, which is tangent to the which is perpendicular to link DC. We do not have its magnitude, so we will just project it upwards. And now we will now draw the normal acceleration for point D, which is normal which is parallel to the link DB, with a magnitude of this one. And now we will also draw tangential acceleration of D, which is tangent to the path of rotation of the link DB, but is also perpendicular to link DB. So we do not have a value for that. We do not have its magnitude. So what we will draw is we will project it towards the tangential acceleration of DC. And from there, we will connect our point Q, the end of our normal acceleration of point D, towards the intersection of the tangential acceleration of D and the tangential acceleration of DC. And then we will have the total acceleration at point D. Now we will solve for the acceleration at point C. We will start off by drawing the total acceleration at point D, which is given by our last analysis. We will copy that over to here, and now we will draw our normal acceleration at ED, which is the direction of it is towards or parallel to the link ED. And we also have this magnitude using the velocity we solved last activity. So now we have drawn its magnitude and direction. It's now time to draw the tangential acceleration of link ED. We don't know its magnitude, but we know its direction, which is perpendicular to link DE, and also tangential in the rotation of link DE, which is a semicircle somewhere here. And now we will project it downwards, and downwards in no matter how long, since we do not know its magnitude. Then we will connect the end or the starting point of the total acceleration of d and project it downwards, and now we will have the total acceleration at point E.